Okay, so I'm going to explain my solution to day 24. So what's going on in this problem? This is another battle problem, although unlike day 15, there's not a grid, so it's simpler. So we have these two armies, and there are groups of units in each army, kind of like the old Heroes of Might and Magic or King's Bounty systems. Anyway, so this group has 1,614 units. They each have some hit points. They have some immunities and weaknesses to types of damage. They have an amount of damage that they do. They have a type of damage that they do, and they have an initiative. So the first thing that we need to do is parse all of this. So that's what I'm doing initially. So keep track of which side we're looking at. And then we have a line that actually represents a group of units. So just split it by spaces. That's the default for split. Grab the number of units, the hit points. If there's resists, then they're in a parenthesized group. So grab the parenthesized group. And we're going to compute the set of immunities and weaknesses. So if there's a semicolon, that means that there's both immunities and weaknesses. So split on the semicolon and then parse both of those pieces. And otherwise, there's just one piece that we need to parse. So the string here is like immune, weak to fire, cold, or bashing, pierce, whatever. So 2 colon means like skip to the list. If you have something that ends with a comma, ignore that. So delete the comma, and then add to the appropriate set, which is either immune if it's immune to, or weak if it's weak to, and it's always immune or weak. You can insert that. So now we want to parse the rest of the information. It's convenient to go from the back because there's sort of an unknown number of parenthesized words of resists, but before the resists and after the resists, the format is fixed. So the initiative is always the last number, the damage type is always the 5th from the last, and the damage is always the 6th from the last. So I just counted that out. Anyway, so that's the entire parsing, and we're going to give each of the units names, which is just like immune 1, immune 2, infection 1, infection 2. So we just keep track of this index of where we are on each list, and whenever we see that we are starting the immune list, we reset that index to 1, and we set the side to 0, and for infection, we reset the index to 1, and the side is 1. So now we have a list of units. So a unit is just has all of these properties. It has some names for debugging. It has the number of units. It has the hit points. It has the list of immunities. It has the list of weaknesses. It has the initiative. It has the damage type. It has the damage per unit. It has the side. And finally, it has a target, which we'll use in a moment. Whew, what a mouthful. Okay, so that's... yeah, that's the parsing. So next we need this, actually one thing that I should have written down, and I will do so now, is the power, which is the n times the damage. So that'll come up a couple times. Anyway. Yeah, and I should probably put this here, too. So yeah, these two useful methods, the power and the damage that we actually do to it to another unit, and that just depends. If they're immune, we do 0. If they're weak, we do twice our power, and otherwise we just do our power. Okay, so now we can actually write the battle function. So because of part 2, this is going to take the list of units and also the boost that we're going to give to the immune system damage. So we're going to make a new list of units. This is important because we're going to modify the units during the battle, specifically the N, right, as units die. So we need to make a fresh copy so that we don't mess with our original units, because we want to reuse them for many battles in part 2. So anyway, for each unit, calculate its damage with the boost. The boost only applies to the immune system. And then just make a copy of all the other fields. Okay, so now let's actually do the battle. We'll figure out what the termination conditions are later. So now we need to go through the steps of the battle. So what is that? So there's two phases. There's target selection and there's attacking. So we're going to do target selection. So in some order, the groups get to choose their targets. The order is by power and initiative. So we can sort by power and initiative. We're doing negative because sorted goes from lowest to highest, but we want the highest power and the highest initiative going first. So we just negate to reverse the order. This is not used, so we're going to keep track of. It also says that you can only. The reason that the target selection order matters is that each group can only be targeted by one other group. So we need to keep track of which groups we've already targeted. And now we can just go through the units and select their target. So in fact, we should just assert, and then we can take this junk out. So we're going to so there's also a priority of targets. So the priority of targets is that you want to do the most damage, then load their power, and then their initiative. So the most damage, their power, and then their initiative. And again, it's all negated because we want the most damage, the most power, and the most initiative, and sorted is going to, low to high. Okay, so what's our targets? This was actually wrong, but it didn't matter. So the list of valid targets is they are actually our enemy. No one has tried to attack them yet, and we're going to do at least 0 damage to them. Let's see. Does it say that? Yes, if it cannot deal any damage, it does not choose a target. So if you do 0, basically you can't attack things that are immune to you. So this is actually a real condition, and it matters because of the only one, each thing can only be targeted by one thing. So like it matters if you get targeted by someone who's going to do 0 damage to you, because that means you can't be targeted again. Cool. And so those are the list of valid targets. Now we need to sort them, and we're going to sort them just according to this function that we've already defined. Okay, so if we actually have some targets, then set our target to the best target. I was having some issue. This is not really necessary. This is obviously true. Whatever, doesn't hurt to assert it. We're gonna just double check that we didn't actually claim this guy already, and then say, okay, we claim this guy, no one else can hit him. Okay, so that is the targeting phase. During the attacking phase, we're going to do damage to the targets that we selected. Again, order matters because you're going to do less damage if you get hit and some of your units get killed on the same round. So it's important to get the order right. And the order is just decreasing by initiative. So we can sort decreasing by initiative, again, decreasing. And we're going to keep track if any units got killed. We might end up in a state where nothing is dying each round, and then the battle goes on forever. The problem statement is not super clear about what should happen in this case, but certainly it's not a win for the immune systems, which is what we're looking for. So anyway, we'll look at that later. So for each unit, if it actually has a target, then figure out how much damage we're going to do to that target, and figure out how many units we're going to kill. So that's, this is slightly unnecessary, but whatever. I wanted to make my debug printing match the problem statement's debug printing. So don't kill more units than there actually are, but the actual number that you kill is the floor of how much damage you're doing divided by their HP. The floor, because there's no partial damage. So you just kill a whole number of units and the leftover damage is worthless. So if you actually killed something, just mark that down, like prove that we're making progress, and sort of delete that many units from the target. So now we are done with the attacking phase. And so now we can do some cleanup and check for ending. So kill all the dead units. Reset all the units to have no target for next round, because we need to redo the targeting. If no progress is being made, then it's a tie. So somewhat arbitrarily, we're just going to give the tie to the infection with its current number of units. Anyway, the problem statement does not really say what to do in the case of a tie. I guess the battle's supposed to go on forever. Anyway, count up how many units are alive on... Again, this should not really be necessary. How many units are alive on each side? So if the immune system is totally dead, then the infection wins with however many units it has. And if the infection is totally dead, the immune system wins with however many units it has. So part 1 is just print out how many units the winning side has in the battle with 0 boost. So 0 boost and the winning side. Part 2 is print out how many units the immune system has left after the first boost that it actually wins. So here we get into ties, and so we just need to say that ties are not good, right? They don't count as actually winning. So the way that we do that is we just simulate the battle with the boost, and if the immune system actually won, then print out like how many units it had left, and then we're done. And otherwise, just keep incrementing the boost until that happens. So I made a bunch of changes as I was going through this code. Hopefully it still runs correctly, which it does not. Now we can debug our refactoring. Cool. So this is supposed to be 2307. Maybe. That's what I printed anyway. That was correct. And now 779. Cool. So that's the correct answers for part 1 and part 2. And that's day 24.